On my screen, we have the Mill Softjaw or the Softjaw Mill project where we left off last class. I can see that I've created the solid model that represents the part. If I look at the solid support geometry level, I have that currently have that invisible. I have the points. I have 2 points on the solid support geometry level. I'd like to move those to level 5, the points level. To do that, I'll start by selecting the points. A couple different ways you can go about doing this. I'm going to do it a slightly different way than I've done it with previous sessions. I'll start by selecting the points first. I'll select all point entities. They become selected. And then in the graphics area, I have my cursor. If I right click from the flyout menu, I'll select this icon here, change level. I would like to move the selected items to level 5. So I can't use the use active level option, so I'll deselect it. And now what I can do is I can type in the level number here, or another method is to select the select icon and pick the points level from here. So we just select it, select OK. You can see that it's now number 5. The name is points. When I select OK, you'll see 2 items appear on the end or for the entities of level 5. So the solid support geometry level went from 8 entities, or went from 10 to 8, and now we have 2 items are now residing on the points level. I'll make the points level invisible. I've got the solid model level active. I'll go back to the project page and let's see what we're instructed to do next. So step 7. Use the curve all edges tool to create the wireframe representation of the part. I'll make the wireframe from solid the active level. I'm going to change the color of the wireframe geometry. I want to mix it up so I'm not using the same color for every wireframe entity. I'm going to change over to, let's say, this burgundy color right here. That might be rough to see with the current background, so I'm thinking maybe something different. Let's see. Let's go with this, not the darker green. I'm going to go with this blue right here. I'll make the solid support geometry level invisible. Once again, the wireframe from solid level is the active level. Anything we create will go on the active level. I'll go to the wireframe tab. Under the curve section, I'll select curve all entities, or curve all edges, I should say. I'm going to triple click the part. And when I do that, the entire part becomes selected. I'll select end selection. And you can see the edges of the part become highlighted. And what's going on is Mastercam is creating wireframe geometry on all the edges of the part. From here, I'll select OK. And you can now see on level 3, the wireframe from solid level, I have 20 entities. If I make the solid model level invisible, we're looking at the wireframe representation of the part. I like to keep the solid model level visible and the wireframe from solid level visible. From here, I'll save my work. And I'll go back to the project page. So we just completed step 7. How's everyone doing up to this point? Take that as good. We're going to move on to step 8. Use the create letters tool to create your first and last initial on the top of the part. Reference drawing for size and text, for size of text and location. I don't think there's any information related to that on the drawing. Let's see. Not seeing it. So what we can do, we'll just create our initials. We'll improvise. We'll make them 0.5 inches tall. Might be slightly different than what I've done on previous projects, but we'll make them 0.5 tall. And we'll just kind of approximate the position. We'll try to center it on this surface the best that we can. I'll go back to Mastercam. And actually, you know what I'll do is I'll center it right on the origin. That's sitting right at the center of this face right now, so that'll work well. change over to a 2D construction plane. So where it says 3D, select it, and it will change over to 2D. I'm going to look at it from a top view. I'm going to go to, and actually, I'm going to make the name level the active level. And once again, I'm going to change the wireframe color. This time I'll change it to this burgundy red. This will be pretty easy to see with the current background color of the part. So I'll change over to this burgundy color. I'll go to the wireframe tab, create letters. I'll enter my first and last initial. And we're looking at the default height, which is a little bit too much right now. So set the height to 0.5. If I position my cursor in the graphics area, you'll see a preview of my initials. I'm going to intentionally place them off of the part at this time. So I'll place them right about here. And then I'll select OK. But before I select OK, if you've selected OK, don't worry about it. I'm going to change over the font style. I'm going to change it to Mastercam box font. And then from here, I'll exit out of the create letters icon or the create letters tool. So I currently have my initials off of the part. I need to reposition them. I want to center them at the origin. To do that, I'm going to use the transform translate tool. So go to the transform tab. In the position section, select translate. Mastercam is prompting us to select entities to translate. You could select them several different ways. Because I have a unique color assigned to them, I could actually come down to this icon right here, the upper left half of this icon, select all entities by color. Select the color here. It's only going to show you the visible colors in this field. So I'm going to select this color here. Yours might be different depending on what color you assign to your initials. I'll select OK. And then you'll see those initials become selected. And then I'll select End Selection. You can see there's a gnomon or a coordinate system centered on my initials. What I'm going to do is I'm going to come over here and select Reselect. So inside the tool for translate, you'll see vector from /2. Underneath, you'll see the icon reselect. Now be careful, there's two reselect icons. One I'm interested in is the one that says, the one that's below vector from 2. So I'll select reselect. Now, if I zoom in, I can let my cursor lock on to the center point, left click, and then I'll let my cursor lock on to the origin, left click, and I'm going to use the move option in this case. So method, set the method to move, and then select OK. I have a temporarily assigned color to my initials. I can right click and select clear colors. And now I can see my initials. I'll do that again, Control Z. I've got my initials placed. I'm going to use the transform translate tool to reposition them. I'll pre-select them. I'll come over to this icon, select all entities by color, the upper left half. I'll select the color that I assigned to my initials. And then I'll select OK. My initials become selected. From here, I can go to transform, translate. I use the vector from 2, the icon below it, reselect. I'll let my cursor lock on to the center point. I'll let my cursor lock on to the origin. And I'm making sure that I'm using the move method. I'll select OK. And then to clear the temporarily assigned colors, right click, clear colors. And now if I look at it from an isometric view, you can see my initials are centered on this top face. Everything appears to be correct. So from here, I'll save my work. How's everyone doing?
Yeah.
Nice. Different ways to use the tools. We're not tied to one method. You can select things before you go into the translate tool. You can select them after you go into the translate tool. If you select the geometry afterwards, you'll have to let Mastercam know that you're done selecting by hitting the end selection icon. So from here, if I go back to the project page, we just completed, let's see here, step 8. Create the letters. So we created the letters. We're now moving on to step 9. Now, step 9, we haven't done anything. Well, we created some material representations, but we haven't created extra material surrounding the part with any of the previous projects. So this one's going to be a little bit different. And I want to make sure everyone's following along with me. So is there anybody that's still hung up on creating the letters? And if you are, and you, it's not to worry, you can always go back and create the letters after the fact. What I'm going to do now is I'm going to create a material representation using the bounding box tool, but I'm going to intentionally leave extra material all the way around the part. So the material is not going to be the exact same size as the part that we're machining. There's going to be extra material on all 6 faces. That way, when we machine it, we get a machine surface all the way around. We're not looking at a mill finish. So step 9, use bounding box tool to create the solid representation of the material. Go back into Mastercam, go to the Home tab, and we're going to assign a new color to the solids that we create. We're going to create a solid representation of our material. We want to use a color that we haven't used on the screen yet or have been used in this session of Mastercam. I'm going to use this color right here, this purple color. I want to make sure that the material level is the active level. Anything we create gets placed on the active level. I don't need to have my name visible at this time, so I'm going to make it invisible. So change the solid color to something that you haven't used yet and make the material level the active level. And then go to the wireframe tab. And we're going to use the bounding box tool. You'll find that in the shape section. Now watch how I do this. I'll do this twice, maybe 3 times. What I'm going to do is I'm going to create a material representation that gives me extra material on all sides of the part. And on the top, I only want around 20 thousandths, 0.02 inches extra material above this top face here. And then on the bottom, I'm going to add 0.23 inches so that we can hold on to something in the vise. So this is how I'm going to go about doing it. Wireframe, bounding box. It says select one or more entities, use Control A to select all. Now be careful, if you have your dimensions visible and use the Control A method, your bounding box is going to include those dimensions or any overlaying or overlapping geometry. In this case, my part is the only thing that's visible on my screen. So if I select Control A, it selects just the part. I'll select End Selection. And I'm missing a dialog box. Actually, I think I'll be okay. So once I hit End Selection, you'll see, oh, I know why. Back up a little bit. And actually, I think you'll be okay, but select the 2D icon and change it to 3D. I've got something else popping up. Hold on. What is this? Okay. So I had it set to 2D. You'll need to change it back to 3D. And it looks like it kicked me out of the tool. So I'll go back to wireframe, bounding box, Control A to select everything that's visible on my screen. I'll hit End Selection. And it's hard to see, but what's happening is Mastercam is creating a rectangular shape that basically captures everything that we selected. And because it was a rectangular shape, the dimensions that we see in these fields are the basic dimensions of our part. So 6 by 1.88 by 1.25. Now, what I'd like to do is I'd like to add material all the way around the part. Now, I want to use numbers that would reflect what we're actually going to machine this from. Chances are we're going to machine this from a extruded piece of aluminum. Usually what I'll do is I'll buy a piece of material. Let's look at these dimensions. I'm thinking 2 inches by 1.5, and I'll get a 12-foot length. So in the Y, let's change the 1.88 to 2 and hit enter. And look what happens when you do that. If I look at it from a top view, it added material in both directions. So the distance from this edge to this edge is 2. And you can see I've got extra material on the front and the back face. We're going to do something similar for the x-axis. Now this will be a saw cut. I would buy a 2 by 1.5 inch piece of material, 12 foot long. The length would be determined by me when I'm cutting up the material with the saw. So let's set this to 2.25. That'll give me an extra 1/8 inch on both sides to remove. And you'll notice as I enter values into the Y and the X, material gets added to both sides. So whatever extra material that I add, it's divided by 2 and it's going in both directions. The Z-axis works a little bit different. If I type in 1.5, watch what happens. It only goes in one direction, and that's not what I want. I want material going in both directions. So what I'll do is I'll change this back to 1.25. To add just 20 thousandths to the top face, I'm going to pick or select the top face, left click. And you should see an arrow pop up in the center. Position your cursor over the arrow. Do not click on it. When you position your cursor over the arrow, you'll see a ruler pop up and you'll see a small blue field. When you see that blue field, you can enter a value. So in this case, I'm going to type in 0.02, enter once, enter twice. And if I zoom in, you can see that extra material has been added to that surface or that face.
What did you select again to do that?
The top face. Let me do that one more time. So 1.25. I selected this top face. So if you're looking at it from an isometric view, select the top face of the part. Then you'll see this arrow pop up in the middle. Position your cursor over the arrow. You'll see a ruler and then you'll see a field pop up next to it. When you see the field, type in 0.02. I hit enter once. I hit enter a second time. And then you can see that the Z value has been increased by 0.02 inches. Now what I need to do is I need to add material to the bottom. This is the material that we're going to hold on to in the vise. And the material, the amount that I add to the bottom needs to add to the 1.27 where that is, so that it equals 1.5. So this is what I'm going to do. I'm going to select the bottom face now. You'll see that arrow pop up again. I hover over the arrow. If I type in 1.5, that's what I'm shooting for. That's the finished number that I want over in this field. So what I did is I typed in 1.5 minus 1.27. And then watch what happens to the value over here and watch what happens over here. I hit enter once. I'm adding 0.23 to the bottom face. I hit enter a second time. Now, if I look over in this field, you can see that the Z, the overall thickness in the Z is 1.5. And if I tumble my view, you can see that I have extra material down here. So what we'll do, we'll hold on to this extra material, face off the 20 thousandths that I left on the top face, and then we'll machine the outside profile to the finished dimensions of the Softjaw. I'll do this a second time. So from here, I can hit enter a third time, or I can select the green check. And I've got my rectangular shape that represents my material. Now I made a mistake. I should have selected create solid and deselected create wireframe. Not a problem. Control Z, I'll do it again. We're using the bounding box tool to create this material representation. I'll go to the wireframe tab, bounding box. Control A to select everything that's visible on my screen. End selection. Now you can see that the dimensions of the bounding box match our part. In the X, I'm going to add 1/4 inch, 6.25. Materials added in both directions. In the Y, I'll update this to 2. You can see if I look at it from a top view, materials added to both faces. The Z doesn't work that way. The Z we have to handle individually. I'd like to add 20 thousandths to the top face here. So left click on the top face, hover over the arrow that sticks out of the arrow that's sticking directly out of the face. 0.02, enter once, enter twice. I'll tumble my view. I'll select the bottom face, hover over the arrow that's coming out of the bottom face. I want the finished dimension of the Z to be 1.5. That's what we're buying from our supplier. To do that, I'll type in 1.5, and then I'll subtract what the Z currently is, minus 1.27. And when I hit enter, the value should be 0.23. I hit enter a second time. You'll see the Z value update in this field. It's now 1.5 inches. If I tumble my view, you can see that the extra material has been added to the bottom of the part. Once again, this will be the part that we hold on to in the vise. Now, where I went wrong with my first attempt, I would like to make a solid model that represents my material, not a wireframe. So come down to create geometry, deselect lines and arcs, and then select solids. And then I'll select OK. And now it's difficult to see. I've got a solid model overlaying the solid model that represents my part. If I go over to this icon, I can turn translucency on. And now it's a little bit easier to see. So this is how I visualize how I'm going to machine this part out of a piece of material. I basically suspend the part within the material. We're now going to use tool paths to remove the material to reveal the part. That's kind of how I like to visualize it in my head. If I look at it from a top view, you can see I've got extra material all the way around the part. If I look at it from a front view, you can see I've got extra material on the top face, 20 thousandths, and then I've got extra material on the bottom face. And this is what we're going to hold on to in the vise. Once we machine the part out, we'll flip the part over and then we'll machine away the excess material that we're holding on to from the very first operation. And I'll show you all that here in a moment. So from here, I'll look at it from an isometric view and I'll save my work. So now that I've created the solid that represents our material, I'll go back to the project page. And we just finished step 9. We're moving on to step 10. Create a new coordinate system and name it first operation. Okay. So if you look at the current coordinate system, it's centered on the top face of the part, and it's actually recessed into the material. So it wouldn't be easy to establish our origin based off of the coordinate system that's embedded into the material. So what I would like to do is I'd like to reposition it so that we could access the material or access the origin with an edge finder or a probe. And what I'm thinking is this corner right here. It could be placed anywhere on the material, but for repeatability reasons, I'm going to place it right here. So if we had a typical Kurt vise, this face would be up against the stationary jaw, and we could set up some type of stop to have a repeatable X. So we're going to create a new coordinate system, and I'm going to place it on the material. We'll call it upper right, bottom of material. We'll go to, we need to make the planes manager visible. So go to view. In the manager section, select planes. To create the new plane, I'll start by selecting create a new plane, and then I'll select from solid face. Pick the top face of the material. And you can see it's pretty much almost sitting on top of the existing coordinate system, and that's all right. The first option that I see, the orientation of the axes, is what I want. If something doesn't look right, you can scroll through the other options. You need to remember we selected a flat solid face, so the z-axis will always be perpendicular to that selected face. There are 8 options where the z will be perpendicular to the selected face. So select the option that you want. I want x running along the length of the part, positive x going to the right. I want y running back and forth, positive y going forward, and then the z-axis is going up. So that's what I'm looking for. Once you have the correct orientation, select OK. We were instructed to call this first operation. To reposition it, I'll select the reselect icon. And once I do that, I move my cursor into the graphics area. You'll see the coordinate system attached to my cursor. I'm letting my cursor lock on to the top right, bottom. When I see it snap into position, left click. Back inside the parameters for this new coordinate system, I have set as, I have WCS checked, T-plane checked, and C-plane checked. From here, I'll select OK. You can now see the new coordinate system is attached to my material. Right click, isometric, and I'll save my work. How's everyone doing? Good. I'll go back to the project page. And step 11, save the Mastercam file as Softjaw to the project folder, also named Softjaw. So we've done that, but just to verify, if I look at the top of my screen, you'll see the path where this file is saved to. And you can see I'm calling this Softjaw Mill. Let's see if I named it incorrectly. So step 11, we're instructed to call it Softjaw. I went a step further and I called it Softjaw Mill. Reason being is there's another project that we'll do, maybe not in this class, but it's called Softjaw Lathe. So I went a step further. I'm calling it Softjaw Mill, and I have it saved to a folder called Softjaw Mill. From here, we have completed the modeling portion of this assignment. We're now ready to move on to the creating toolpaths portion of the assignment. So before we move forward, how is everyone doing with the first half or the first segment of this assignment? Everyone good?
Yeah.
Perfect. Okay. So I'm going to move on to the creating of the toolpaths. Step 1, just like every other project that we worked on, we're going to make the toolpath manager visible and import a machine definition. We're going to import the default machine definition, and then we're going to make some changes to it. So I'll talk about steps 1 and step 2 at this point. So step 1, we're going to make the toolpath manager visible, bring in machine definition. Step 2, we're going to modify the settings in the machine definition. Reference machine group properties found below. So I know these, I don't need to reference these pages, but if you ever feel the need or you're not quite sure what goes where, you can look at these samples or examples. So let's take care of steps 1 and 2 at this time. I'll bring up the toolpath manager. I'll go to view. In the manager section, I'll select toolpaths. I'll go to machine. So toolpath manager is visible. You can see that there's nothing currently in the toolpath manager. Go to the machine tab. From machine type, expand mill, and then select, I'm going to use the mill default.mcam-mmd. I believe it's the same as the default. So if you hit default or this one, you'll get the same thing. So I'm selecting mill default. It brings in a generic machine group. If I expand the properties underneath the machine group, you'll see files, tool settings, and stock setup. Before I do anything to the machine group, I'm going to come back up to file. So there's file here, then there's file in the machine group. Go up to the sessions file. So Mastercam file, and then select project manager. Inside the project file manager, I want to set NC files, or I would like to select NC files and NCI files. And what we're doing is we're telling Mastercam to save these types of files to this location when we create them. That way they end up in the project folder and we're not searching for them at a later date. So from here, I'll select OK. To get back to Mastercam, I'll select the back arrow. The next thing I'll do is I'll select the files. So once again, I'm selecting files, but this time it's under the properties of the machine group inside the toolpath manager. So select files under properties. I'll start by renaming the group. I'll call this Haas VF2. Rename the group. I'll select edit. Under mill spindle group, if you expand it and then keep expanding it until you see tool spindle, double click on tool spindle. You can see that the maximum spindle speed is set to 50,000. Our machines are not capable of 50,000 RPM. We're going to set this to 10,000. And Mastercam will use this when it comes time to calculate RPM. It will never exceed 10,000 RPM. From here, I'll select OK. We're done with everything that we need to change on this page, so I'll select OK again. Brings us back to this page. We have completed all of the changes that we need to make on this page. Select the Tool Settings tab. The default program number, this will be a 4 to 5 digit number of your choice. When you're programming for a Haas machine, avoid using 9000 series numbers. Those are usually reserved for other programs, for the Renishaw Probe or some other programs that the machine builder would be using. So I'm going to select a 4-digit number. We'll call it 8050. This is just a number that I chose randomly. For the feed calculation, select from material. For toolpath configuration, check assign tool numbers sequentially, check warn of duplicate tool numbers, and check use tools, step peck, and coolant. Once you do that, go down to the sequence number. Let's start with 1, then have our lines numbered in increments of 1. These will be the line numbers inside of our NC file. For the material, I go back to the blueprint and scroll up to the top. They've identified the material in the title block of the drawing. They're saying use 6061-T6, that's aluminum. We'll choose something close and then we'll modify it to match the drawing. So back inside of Mastercam, the default is aluminum inch 2024. So let's select aluminum inch 6061. Select the select icon. Not much to choose from, so right click in the field, select get from library. I'll select aluminum inch 6061. Select OK. I'll select OK again. And you can now see that the current material for this session of Mastercam is aluminum inch 6061. We're going to make some changes to the material definition. Select edit. For the material, I don't need to specify inch. I'll call it aluminum 6061-T6. For the base cutting speed, set this to 300. For the percentage of the base for drilling operations, it's currently set to 60. Left click on it one time, hit the enter key, and now I can type in 50. So when I have Mastercam calculate my feed rates, it's going to use 300 for most operations. Let's see here. Oh, because I have drill selected here. But I'm sorry. For drilling operations, it'll calculate the RPM using an SFM of 150. And then for contour, pocket, we're not using a surfacing toolpath. So we will use a contour toolpath and we'll use pocketing toolpaths. It's going to use 300 for the SFM when it calculates the RPM. From here, I'll select OK. That'll complete all the changes that I need to make to this page. Go to the stock setup tab. For the stock planes, let's set this back to top. So I'll select the, looks like a calendar. I'll select this icon. At the very top, you'll find top. So I'll select top. I'll select OK. For the shape, this is the shape of our material. We created a,
Professor?
Yes, sir.
Sorry, real quick. You said, where'd you do that top thing again?
Okay, so under stock setup,
huh?
You'll see stock plane.
Uh-huh.
Select this icon right here. It looks like a calendar.
Yep.
And then grab this slide bar and go all the way to the top. I want to make the top the active stock plane. And then when you select OK, brings us back to this page, and you see that this is now top.
Got it. Thank you.
You're welcome. So for the shape, now we created a solid model that accurately represents what our material is going to be. So I'm going to select solid/mesh, and then I'll select this icon. It looks like a cursor. When you select this icon, it allows you to go back into Mastercam and select the solid that represents our material. Now be careful. Don't select the solid that represents our part. So I'll carefully select the solid that represents, the solid that represents my material right here. It's just like this. Tumble my view. I can still see the part through the material. So I'll carefully select just the material. And if I did it correctly, you'll see the values in these fields now represent the dimensions of my material. So 1.5 by 2 by 6 1/4, that's correct. To double check the placement and the size, I'll select display. I'll select solid, and then I'll select OK. Now it's difficult to see the stock that we're going to see inside of Verify is overlaying the stock, the solid that we created that represents our material. So a way for us to check it, if you were to go to the level manager, make the material level invisible. And I'm just toggling off the visibility of the material, toggling it back on. You can see that it overlays the material representation that we're going to see inside of Verify. It should. I just want to double check it. Now, a situation that you might come across. Now, don't follow me down this path. I'm just showing you a problem that might come up, and I want to show you how to troubleshoot it. So if I go back to my toolpath manager and go to stock setup, this stock plane, when I first came to this page, when I first opened up this page, it was set to first operation. Don't do this. Watch what I do. I'll set this to the first operation. I'll select OK, and watch what happens to my stock. So my solid model, the model that represents my material, is where it's supposed to be, but the stock for our Verify has been shifted off of the part. And that's not what we want. And that's why I keep my stock plane set to top. So if you ever see anything like this, the majority of the time you can fix it by going back to your toolpath manager, go to stock setup, and change your stock plane back to top. Select OK, select OK. And now the stock for verify is overlaying the solid model that represents our material. That's what we want. Sometimes you'll go into verify, you can see your part and you'll see the material shifted off to some side or rotated funny. So you want to make sure that the stock plane is at the top. It's very rare, extremely rare that I have it changed to anything other than top. So once I verify that the stock is in the correct location, I'll toggle off the display. I'll go back to the toolpath manager. One more thing I want to change before I start bringing in stock models and creating toolpaths. This toolpath group 1, this is a generic name. I'm going to rename the toolpath group and I'll call it first operation. To do that, I'll right click on it. From the flyout menu, I'll go to groups and then I'll select rename. I'll call this first operation. And then I'll save my work again. So I'll look at it from an isometric view. I like to fit my screen and I'll unzoom 80%. Save my work. If I go back to the project page and I go down to the toolpaths, step 3, it says use a face toolpath to clean the stock from the top of the part. Before we create any toolpaths, I like to create a stock model. Stock models will reside in the toolpath manager. We're going to create a stock model that represents the material before we did any machining to it. And we're going to use that solid model that represents our material to define that. So we're going to actually have 3 representations of our material floating around inside of this session of the Mastercam. One's used for verify. One will be a stock model that we're going to see inside of the toolpath manager. Then the other one's a solid model that the other 2 are dependent on. So from here, I'll go back to Mastercam. I want to create a stock model that reflects what the material is going to look like prior to any machining. And we're going to use a solid model that represents the material to define that. I'll go to the toolpaths tab. In the stock section, I'll select stock model. Brings up the parameters for the stock model. Let's call it raw material, raw stock, something that makes sense. Just like we did for the stock that we see inside of verify, set the stock plane to top. So I'll uncheck stock plane, then it defaults to top. For the initial stock shape, once again, I have a solid model that accurately represents my material. So I'll use model. I can select this icon, the cursor looking icon. That allows me to get back into Mastercam, and now I can pick select that solid model that represents my material. I'll select OK. And that'll take care of everything we need to do for our first stock model. We don't have any source operations with the very first stock model. There's no machining done to it. So from here, I'll select OK. Once again, it's difficult to see because it's overlaying the solid that it's defined from. If I go back to the level manager, and I make the material level invisible, you can now see the gray representation of our part. I'm sorry, the gray representation of our material. And that's why I try not to use the gray color for my solid color. It matches the stock model color or the default color for the stock model. So I steer clear of using gray for my solid color. So from here, I can make the material level visible again. I'll go back to the toolpath manager, and to toggle off the display of that stock model, I can select this icon, toggle display. Look at it from an isometric view, and I'll save my work. How's everyone doing?
Good.
Doing good? Perfect. Okay, so we'll go back to the project page. Step 3, use a face toolpath to clean the stock from the top of the part. If I scroll to the bottom of the project page, you'll see the tool list. So tool 1, we're going to use a 3-inch face mill, 6 flute or 6 cutting edges. And for the tool holder, we're just going to use a default tool holder in this case. Go back to Mastercam. Make sure that the insertion arrow is at the very end of your toolpath group. This is where the toolpath is going to be placed. Go to the toolpath tab. In the 2D section, we're going to use the face toolpath. Now, if you're not seeing the face toolpath here, expand the gallery, then you'll find it here. In my case, it just happens to be visible. So I'll select the facing toolpath. That brings up the wireframe chaining dialog box or the chaining dialog box. Now, what I need to do here is I need to select the top edge of the solid that represents my material. So the wireframe chaining method is not going to work. I don't have a wireframe representation of the top of my material. Not a big deal. We're going to switch from wireframe mode to solid mode. So where it says mode, you can see that the wireframe one is currently active. Select solids. You can see the chaining dialog box now changes over to a solid chaining, and the selection methods have changed also. So keep the C plane selected. And then for the selection method, I'm accepting the defaults. I've got loop selected and I have face selected. With those 2 items selected, I'll position my cursor close to the outer edge of the material, not the part. This is the outer edge of the material. When I see the outer edge highlight, left click. You can see that the outer top edges become selected, and then there's an arrow pointing in a clockwise direction. I want this arrow to go in a clockwise direction. If it's not going in that direction, you can flip it with this icon. And because it's a facing operation, it probably won't make a difference, but I'm in the habit of making my chains go clockwise for external features and counterclockwise for internal features. So top edge is selected. From here, I'll select OK. Go to the tool. Currently don't have any tools in my tool list. To add a tool to my tool list, you can right click in this blank area and select the select library tool, or you can come down to this icon. So it's accessible several different or several areas or several places. I'll select the select library tool icon. And my filter is active. It's showing me only the face mills. Chances are you're not seeing just face mills. So let's just go to the motions. Filter active is checked. I'll select the filter icon. Let's assume that all tool types have been selected. So I have all tool types selected. I'll start by deselecting all tool types. I'll select none. Then I'll select face mill. Now, if I leave the tool diameter set to ignore, it's going to show me all the face mills coming out of this library. There might be 8 or 9. So I'll leave this set to ignore. And then I'll select OK. And there are 8 to select from. We're instructed to use a 3-inch face mill. So tool 324, if I double click on it, it's added to my tool list as tool number 1. Now remember, under tool settings, we checked assign tool number sequentially. If you're seeing tools coming in with the number that's assigned to them in the library, you're going to need to change that. We do not have the ability to hold on to 324 tools or whatever that tool number was, whatever the tool number was that was assigned to the face mill. So tool 1 is my 3-inch face mill. I'll need to make some changes to the default settings. Once it's added to your tool list, right click on it, select edit tool. On the first page, I'm not going to make any changes. I'll just accept the default settings or the default values. So from here, select next. Set the number of flutes to 6. If I calculate the RPM, it's using that 300 SFM. We're actually going to change the SFM when we get over to this field. We're going to actually bump that up to 900 SFM. But for now, change the number of flutes to 6. You could select the calculator. We're going to change it, so it doesn't matter if you select it or not. Select show more options, select coolant, and then set the flood coolant to on. I'll select OK. And that'll complete all the changes that we need to make to this page. So I'll select finish. I'm looking at the RPM. So this 300 for a face mill cutting aluminum is a little slow. Let's bump this up to 900. And my spindle speed or my RPM is now calculated at 1,146. Let's set the FPT to 5,000s. Now, what I'll normally do, I'll reference the manufacturer's recommended SFM and FPT for face mills. They're usually inserted or indexable. And on the box of inserts, depending on the material that you're cutting, depending on the material that the grade of the carbide inserts, they will give you an SFM and an FPT. So in this case, I'm going with what I know works. The SFM 900, FPT 0.005. It's giving me a feed rate of 34.38. Let's set the plunge rate to half the calculated feed rate. So 34.38, divide that by 2. My plunge rate is 17.19. I have rapid retract selected. And in the comment field, I will borrow the tool name. And we'll say face, all caps, face top of part. How's everyone doing up to this point?
Good.
Nice. Okay. From here, if you look at the holder, now we're instructed to use the default holder. I don't have the exact holder and the exact profile of the cutter that we have at the school. So we're just going to go with the default values here. Let's go to the cut parameters. Now the style, mine's set to 1 pass. There's a chance or a high probability that yours is set to 1 way or zigzag. In this particular case, the part is only, I think we got 1.5 by 2. So if the width of the part that we're facing is less than the diameter of the face mill, we can get away with using 1 pass. And this graphic pretty much shows us what the tool path is going to look like relative to the tool and the tool path relative to the part. The diameter of the cutter is greater than the width of the part. We're going to run this face mill right down the center of it. So that's what you're seeing right here. For the approach distance, yours is probably set to 50. I've got mine set to 10. And then the exit is also set to 10. And then where it says stock to leave on floors, I have this set to 0. There's a good chance that yours might be set to 50 thou, 0.05. So I've got the style set to 1 pass. approach distance 10%, exit distance 10%. Then I got stock to leave on floor set to 0. If you had to change these values, select this icon right here. This way, these values will become the default setting or default settings next time you use this facing operation. So I'll select this icon here, save parameters to defaults file. It's letting me know that the library has been updated successfully.
You mean click the floppy disk, 3.5 floppy disk button?
Yes, it's a little dated, but that's what that means, save. Wasn't there a 5-inch one prior to that?
Yeah.
That was
I think maybe the ones that know what that is.
Yeah, exactly. Oh, when I started there at City College, all the computers had the zip drives in them, those 100 megabyte zip drives. I don't know if you remember those or not.
Oh, yeah.
So we had, those were how we saved all of our work. We didn't have the USBs. We had the Mastercam files back in that day were a little larger than your typical 3.5-inch floppy. So we had to use the 100 megabyte zip drives. And those were standard on all the computers in the computer lab. Little throwback there.
Nice, nice.
Okay, so from here, I'll go to depth cuts. Now, remember, we're only taking about 20 thousandths of material off the top of the part. So we don't need to do this in multiple depths of cut. This is aluminum. Our speeds and feeds are pretty conservative. They're not aggressive. And we're only taking 20 thousandths of material off. So I'm okay with not using depth of cuts. We're just going to do this in one pass. So from here, go to linking parameters. Once again, I want to set my clearance to 2 inches above the top of the part. You need to remember that the origin is at the bottom of the material. So 2 inches above the top of the part is going to be greater than 2 inches. So activate clearance. I've got it set to absolute. What I'll do is I'll select the clearance icon, and then I'll select the top of the material. So relative to the origin, the top of the material is 1.5 inches. Add 2, so +2, hit enter. For this project, I'm going to use a clearance plane of 3.5 inches. Oh, let me back up a little bit. For the first operation, our clearance plane will be 3.5 inches absolute. So any toolpath inside the first operation, I'm going to use this clearance plane. This will be a repeating clearance plane. I'll check. I don't need to check use clearance only at the start and the end of the operation. This is going to be a one pass, so this won't have any impact on what we're doing. Retract. I'll set it to incremental. And actually, I can turn retract off in this case. Set your feed plane to 0.1 incremental. Top of the stock, I have it set to absolute. I'll select the top of stock icon. I'll let my cursor lock on to something that represents the top of the part. It's 1.5 absolute. And then for the depth, I'll set that to absolute. I'll select the depth icon. Now I'm going to zoom in, and I'm going to let my cursor lock on to something that represents the top of the part, not the top of the material, the top of the part. I see it lock on, left click, and you can now see that the depth relative to the origin is at 1.48 inches. The difference between these two, that's that 20,000, that 0.02 that we left to machine, or that's what we left on the top of the part, so that we can machine it away and get a nice machine surface on that top face. So top of stock is the top of the material. Depth is the top of the part. From here, that should take care of everything. I'll select OK. I'll zoom out a little bit. I can fit my screen. You can see our toolpath. It's actually, looks like 3 lines. We're rapiding down to our feed plane. We feed to our depth of cut. We do one pass across the top of the material. We're taking 20 thousandths off, and then we wrap it away. That's all this toolpath is doing. With just that toolpath selected, let's see what it looks like inside of Backplot. I'm hitting the S key. I'm just single stepping through the toolpath. So it rapids down to the feed plane. It feeds to its depth of cut. I'll play it real slow. It's feeding across the top of the material, taking 20 thousandths off. If I zoom in, you can see the slight how the cutter is moving through the material. It's going to clear the part. And then it's going to wrap it away from the part. Not much going on here. We're just taking 20 thousandths off the top of the material. So from here, I'll exit verify. I'm sorry, exit Backplot. I'll toggle off the visibility of the toolpath. I look at it from an isometric view, fit the screen, unzoom. Now I'd like to run it and verify, but before I go into verify, I would like to save my work. So file, save. I don't want to lose anything that I've done. So if I go into verify and it crashes, I want to make sure that this work is done or this work is still here when I reopen Mastercam. So now with the first operation selected, I'll go to verify. Takes a moment to open up. Inside of verify, make sure that stop condition collision is turned on. I can hit the S key. Single step through it just like I would Backplot. Maybe not. Now, if I zoom in, you should see the top face of the part that becomes visible. So we took 20 thou off and we're now revealing the top face of the part. I don't have any collisions. Everything looks to be good. From here, I'll select or I'll exit verify. And I've already saved my work, so I don't need to save it again. To free up space inside of the toolpath manager, once I complete a toolpath, I'm going to minimize the stock model and minimize the toolpath. If I ever need to get access to the parameters, I can always expand it and then select these items from here. You can also make the size of the font larger or smaller inside of your toolpath manager. If you select this icon, options, font, you can increase the font. Let me go back here. It's currently set to 9. I can see that well enough, but if you can't, depending on the resolution of your screen, if you increase that, see, that's a little extreme. One thing I don't like, it doesn't seem to update the size of the icons relative to the font size. So in this particular case, I'll keep it at 9. I can see that well enough. Hopefully you can too. So from here, we're going to create a stock model that reflects what the facing operation has done. Make sure that the insertion arrow is at the very end of your toolpath group. Go to the toolpath tab. In the stock section, select stock model. Let's call this one face top of part. For the initial stock shape, we're going to use a stock model that we created that represents the raw material. So I'll select stock model. Only one stock model to select from at this time. So raw material. And then for the source operation, select that facing operation that we just created. I'll select OK. Now it's difficult to see, but if I zoom in, you can see the stock model is 20 thousandths shorter than the material. So it's reflecting what the facing operation did. It took 20 thou off the top of the material. So that's exactly what I wanted to see. Once I verify that it's correct, I can toggle off the visibility of the stock model. Look at it from an isometric view, and I'll save my work. How's everyone doing?
Good.
Good. Okay. I'll go back to the project page. And we're moving on to step 4. It says use a contour toolpath to remove the majority of the material from the outside profile of the part. And I'm going to fast forward a little bit. Step 5, use a contour toolpath to machine a finish pass for the dedicated finishing tool. So in this particular case, we're going to take a end mill and we're going to dedicate this just to the roughing process. And we're going to intentionally leave material on the wall so that we can come in with a dedicated finishing tool. So let's take a look at our tool list and see what's available to us. So tool 1 was the face mill. Tool 2, this is the 1-inch flat end mill, 3 flute. And this is what we're going to use as a roughing tool. And then for tool 3, we're using a 3/4 inch flat end mill. So the roughing tool is going to remove the material quickly, but it's not going to leave a great finish. But then we're going to come in with a dedicated finishing tool, and it's going to leave a much nicer finish. It's going to do a lot less work, and we can dedicate a brand new tool to the finishing process, where we could have a slightly used tool dedicated to the roughing process, where we might even have a roughing tool that uses indexable inserts, and it's just not capable of leaving a great finish. So different methods. A lot of times when I'm cutting, especially when I'm cutting things other than aluminum, I'll have a dedicated roughing tool and a dedicated finishing tool. So in this case, we're going to use a roughing or the 1-inch to rough out the majority of the material. We'll intentionally leave, let's say, 1% of the tool diameter on the walls. And I'll show you what that means in a second. So from here, we're going to create a contour toolpath. From the toolpath tab in the 2D section, select contour. Now it's still in a solid chaining mode. I'll change back to a wireframe chaining mode. So mode is set to wireframe. C plane is selected. Selection method is now a chain. If I zoom in and I hover over this edge, it's selecting the wireframe geometry that I used, or the wireframe geometry that I created from the solid model of the part. When I see it highlight, left click. So this is selecting the top edge of the part, not the material. And you can see that the chain's going in a clockwise direction. From here, I'll select OK. Brings us to the parameters for the contour toolpath. Go to the tool. We're going to add a 1-inch flat end mill to our tool list. So I'll select library tool. Filter is active. It's looking at chamfer mills in my case. Let's assume that the filter is not active. So check filter active, select the filter icon. Let's assume that all tool types are selected. Deselect all tool types by selecting none. And then select end mill flat. And where it says tool diameter, set it to equal. And then set the value to 1 and hit enter. So we're going to look for a 1-inch flat end mill. I select OK. I've only got one option or one tool that fits that description. It's tool 297 in my case. If I double click on it, it's added to my tool list as tool number 2. I'll need to make some changes to it. So right click on it. From the flyout menu, select edit tool. And I'm looking at the default settings. Let's check the tool projection that we're told to use. And it says tool 1, 2-inch tool projection. If I look at the shoulder length, yeah, it's going to require us to use a tool projection of 2.5. So what we can do is we can make some changes to this. Let's set the cut length to 1.75 and then set the shoulder length to 2. Oh, didn't like that. Set the shoulder length to 2. And that will allow us to have a tool projection of 2 inches. So we're just matching what's going on with the tool list. I had to make these adjustments so that I can set the tool projection to 2. So cutting length, 1.75, shoulder length, 2. From here, I'll select next. Let's start by setting the number of flutes to 3. To calculate the RPM, I'll select the calculator icon. To turn on the coolant, I'll select show more options. I'll select coolant. And then I'll set the flood coolant to on. From here, I'll select OK. For the rough step, or I'm sorry, for the finish XY step, this is how we can control how much material we're going to leave on the walls, but we're not finishing with this tool, so we're going to leave this alone for now. To recap what I did here, I set the number of flutes to 3. I calculated the RPM. I turned on the coolant. Select finish. You can see that the RPM is based off of this 300 SFM. I want the FPT equal to 1% of the tool diameter. So if you type in 1 times 0.01, it's 0.01. My feed rate is calculated at 34.38 inches per minute. Let's set the plunge rate to half the calculated feed rate. So 34.38, divide that by 2. I've got rapid retract selected. And for the comment, I'll need to update that. I'll start by copying the tool name. In all caps, provide some type of note or message to the operator, something that would be useful to us out at the machine. Say rough machine outside contour. And that'll complete all of the changes that I need to make to this page. So from here, go to the holder. Now, if you look at the tool list, we were instructed to use a specific tool holder. It's a Cat 40-inch tool holder. It's a C4 E3-1000. Instead of looking through this long list of tool holders, I'll select Open Library. I'll select Cat 40-inch, open up that tool holder library. And we're looking for a C4, and let me double check that. C4 E3. I might have made a mistake on that. C4 E3-1000. So this is a solid type tool holder. It would require us to have a flat ground on the side of our tool because there will be a set screw that will need to land on the flat. So C4 E3-1000. We're also instructed to set the tool projection to 2 inches. So that completes all of the changes that we need to make to this page. From here, go to cut parameters. Compensation type, I have mine set to wear. Contour type is 2D. Stock to leave on walls. Now we're intentionally going to leave, let's say 1% of the tool diameter. So actually, let's do 2% of the tool diameter. So if I type in 1 times 0.02, we're telling Mastercam to leave 20 thousandths on the walls so that we can come in with that dedicated finishing tool. We don't want to machine it to the finished dimension and then come in with a dedicated finishing tool. It might not clean up. So we're intentionally leaving material on the walls. I'm not worried about the floors at this time. If I go to depth cuts, the depth that we're cutting to is greater than half the tool diameter. So we're going to activate depth cuts. If I do it in 2 or 3 depths of cut, I believe 3 depths of cut, I'm not worried about finished cuts on the floor. All that extra material is going to get removed anyway. So in this case, I've got depth cuts activated. I also have keep tool down selected. That'll complete all of the changes on this page. Let's go to lead in out. Now, the default settings are a little excessive. These might be set to 100%. So what I did is I set these to 25%, and then I carried it over to the exit. So 25, enter, 25, enter, and then I carried it over to the exit. And now I've got the same values here and here. Breakthrough. In this case, I'm going to activate breakthrough. I want the cutter to go slightly beyond the bottom edge of the part, not the material. It's just going to go a little bit deeper, slightly beyond the bottom edge of the part. And let's set that value to 20,000, 0.02. Multi-passes. This is something that we would use if we were roughing and finishing with the same tool. We're not finishing with this tool, so I'm going to leave multi-passes off. From here, go to linking parameters. Activate our clearance plane. Now we're going to use the same clearance plane that we use with the facing operation. So I know this, I remember this, 3.5. I've got to set the absolute. I could check use clearance only at the start and the end of the operation. I'll turn retract off in this case. Feed plane, 0.1 incremental. Top of stock, I've got to set the absolute. Now this is a little, you could do it one way, you could do it the other. If I select top of stock, I could select the top of the material, but if I wanted to be more accurate, I could select the top of the part. You need to remember that the top of the material has been machined down to this Z level, the top face or the top edge of the part. So the top of the stock is now 1.48 relative to the origin. The depth, I'll set it to absolute. I'll select the depth icon. This time, I'm going to select the bottom of the part. Be careful, do not select the bottom of the material. If you select the bottom of the material, you're going to machine into the jaws of the vise. You need to remember how we're holding on to this material. We're going to put this in the vise and hold on to about 150 thousandths of this material. So I'm going to select the bottom of the part. And you can see that the bottom of the part relative to the origin is 0.23. So this all looks good. From here, I'll select OK. I'll fit my screen. I'm not seeing any issues at all, actually. But let's run it and verify. So let's run it in backplot and see what we get. So with just that toolpath selected, I'll select backplot. I can hit the S key to single step through. It descends to its first depth of cut. Removes the majority of the material, goes to its next depth of cut. Same thing. It goes to a third depth of cut, and then it's done. So I like what I saw in backplot. I'll exit backplot. I'll toggle off the visibility of that toolpath. I can look at it from an isometric view, fit my screen, unzoom. Before I go into verify, I'll save my work. inside of verify, or before I go to verify, select all of select the entire first operation toolpath group. Everything has a green check next to it. I'll select verify. Once again, make sure stop conditioning collision is turned on. And I'll select play. That was pretty quick. Once it's done running and verified, I like to zoom in and I'm inspecting the machine model. I'm comparing the machine model to the wireframe representation of the part. And if you zoom in, you can see that we still have material that needs to be removed. So we intentionally left this material on the wall. It's not much, but we're going to come in with a dedicated finishing tool and machine a nice finish, or machine this to the finished dimensions, and we'll have a nice finish all the way around the part. So I like what I see. I'll exit verify. The next thing we'll need to do is we'll need to create a stock model that reflects everything that the machine, that reflects everything the toolpaths have done up to this point. Insertion arrows at the very end of my toolpath group. Go to the toolpaths tab. In the stock section, I'll select stock model. We'll call this one rough outside contour. For the initial stock shape, I'm going to select the stock model from the previous operation. And then for the source operation, I'll select the contour toolpath that we just created. Now it's difficult to see, so I'll go back into the level manager. I'll make the solid model of the material invisible. And this is what the part's going to look like in the machine after the first two toolpaths. This extra material down here, this is what we're holding on to in the vise. We have to hold on to something. We can't just have it magically held in space. So we're clamping on this edge or this face and this face. And we just need to be careful how deep we send the tool so that we don't machine into the hard jaws, damaging the hard jaws and more than likely damaging the cutting tool. So this is what the part looks like after the first two toolpaths. So from here, I'll toggle out the visibility of that stock model and I'll save my work. So now that we've created the stock model that shows the roughing of the outside profile, we're going to move forward and we're going to create the toolpath for the finish operation for the outside profile. We're going to use a 3/4 inch flat end mill, same type of toolpath, but instead of using multiple depths of cut, we're just going to machine this at one depth of cut. So I'll go to the toolpaths tab, 2D section, once again, contour. For the mode, I'm using wireframe. I have C-plane selected, and the selection method is still chain. I'll select the top edge of the part right about here. You can see the chain going in a clockwise direction. I'll select OK. Brings up the contour toolpath, select the tool. Let's bring in a 3/4 inch flat end mill. So I'll go to select library tool. Filter is still active from the last time that we selected a tool, so I'll select filter. In this particular case, we're looking for a flat end mill. I'm going to change the equal, well, the tool diameter, I'll leave it at equal, but I'll set the value to 0.75, or you just type in 3 divided by 4, 3/4. Looking for a 3 or a 0.75 diameter flat end mill, I'll select OK. There's one tool that fits that description. It's tool 294. When I double click on it, it's added to my tool list as tool number 3. We'll need to edit the tool. So right click on the tool, select edit tool. For the cutting length and for the shoulder length, let's reference the tool list. Let's see what the tool projection, or let's see what we're instructed to use for the tool projection. So tool 3, it says tool projection is 2.5 inches. To make that happen in Mastercam, let's the shoulder length. So this will work just fine. The shoulder length is the minimum tool projection. So I could actually increase it a little bit, but the more you increase it, the less you're holding on to. So we want to make sure that there's enough engagement into the tool holder. So in this particular case, the shoulder length, this will be our tool projection. This will work. So from here, I'll select next. Number of flutes. Once again, we're instructed to use a 3 flute. To calculate the RPM, I'll select the calculator. To turn on the coolant, I'll select show more options. Select coolant and then set the flood coolant to on. And then I'll select OK. For the finish XY step percentage, once again, this will have no impact on what we're doing. We're only removing 20 thousandths, or a small amount that the previous tool left on the wall. So I'm not going to change anything here. I'll select finish. So the RPM is based off of this 300 SFM. That's correct. For the FPT, set the FPT equal to 1% of the tool diameter. So in this case, I've got the decimal equivalent right here. 0.75 times 0.02. I'm sorry, 0.01, 1%. My feed rate is being calculated at 34.38 inches per minute. Let's set the plunge rate to half the calculated feed rate. So 34.38, divide that by 2. I have rapid retract selected. And in the comment field, I'll borrow the tool name. And then in all caps, I'll type in some useful information. Machine finish pass. Outside profile. And that'll complete all of the changes that we need to make to this page. Go to the holder page. We're instructed to use C4E3-0750. Tool projection is 2.5 inches. So once again, instead of looking through this long list of tool holders, I'll select Open Library. I'll look in the CAD 40-inch tool holder library. C4C3, I'm sorry, my bad, C4E3. C4E3-0750. And then set the tool projection to 2.5. From here, go to cut parameters. Most of these settings will carry over from the previous contour tool path that we used. The thing that we'll need to change, where it says stock to leave on walls, set this to 0. That was from the previous tool path. We're machining it to the finished dimensions. That completes this page. You go to depth cuts. Now, we're going to machine this in one depth of cut. It's not taking a ton of material off. It's just taking a small amount of material. So I'm going to turn off depth cuts. It's going to machine it in one pass. Lead in, lead out. I'll leave these settings alone. These are good. These are my default settings. Breakthrough. I use breakthrough on the first tool, so I can use the same amount of breakthrough for the second tool. You don't want to use breakthrough with our finishing tool if the roughing tool didn't break through to the bottom or break through a certain amount. So match this to what the roughing tool did. And if the roughing tool didn't have a breakthrough, turn it off. Multi-passes, once again, we're just machining it with one pass. We don't need multi-passes in this case. The roughing tool took off the majority of the material. Linking parameters. Let's see here. So clearance, all tool paths for the first operation will have a clearance plane of 3.5 inches absolute. Feed plane, I have it set to 0.1 incremental. Top of stock, I have it set to absolute. I'll select the top of stock icon. I'll select the top of the part. It's 1.48. And then for the depth, I have it set to absolute. I'll select the depth icon. And this time I'll select something that represents the bottom of the part. And the depth should be 0.23 absolute. From here, I'll select OK. Toolpath, things I'm checking for rapid moves, moving through the material. Feed moves, moving where they shouldn't be. So everything appears to be correct. So I'll run it and verify. I'm sorry, run it and backplot. It makes its descent to its depth of cut. It arcs into the part and it starts working its way around the profile. If I look at it from a top view, you can see that the cutter is right up against the edge of the part, and that's what we want. All right, so it arcs off of the part, wrap is away from the part. So I think all of that looks good. So I'll exit backplot. I'll toggle off the visibility of that tool path. I'm looking at it from an isometric view. Probably a good idea for me to save my work. And what I would like to do is I'd like to run everything inside of Verify at this time. I'll select the first operation toolpath group. Everything has a green check next to it. I'll select Verify. Stop condition collision is still turned on. And then I'll select play. Once you're done running it inside of Verify, inspect the machine model. And as I zoom in, now the closer you zoom in, you can see some limitations of my graphics card. It's not perfect, but you can see that for the most part, the machine model matches the wireframe representation of the part. And if I zoom in down here, you can see that the machined edge goes slightly beyond the bottom edge of the part. So we've intentionally gone a little bit beyond. And what's going to happen is we're going to flip this part over and we're going to machine away this extra material that we're holding on to for the first operation. So everything looks to be good. I'm not seeing any collisions. I don't see the tool rapiding through the part. So everything looks good. I'll exit Verify. Hit the screen and unzoom. And I'll save my work again. We'll need to create the stock model that reflects all of the machining operations up to this point. Make sure the insertion arrow is at the very end of the toolpath group. Go to Toolpaths, Stock Model. For stock definition, we'll call this one Finish Pass Outside Profile. For the initial stock shape, we're going to use a stock model created from the previous operation. So stock model, rough outside contour. And actually, just to be consistent with the naming, I'll call this one outside contour. From here, I'll go to the source operation and I'll select the contour toolpath that we just created. Select OK. Just like inside of Verify, I'm going to inspect the stock model. I'm just comparing it to the wireframe representation of the part, and you can see everything kind of lines up, looks good. You can see that we still need to remove the material inside of the drilled and counter bored holes. So once you verify that it's correct, toggle out the visibility of it and save your work again.